Hi guys, Miss Kramer here. We are going to look at my review video on section 11.1, which was simplifying radicals. Now in that section we went over a lot. We did some examples with removing perfect square factors, removing variable factors, multiplying two radicals, simplifying fractions with radicals, simplifying radicals by dividing, and then rationalizing a denominator. So I'm going to do two examples from each section. Feel free to fast forward, pause it, whatever you need to do in order to study for this test. So let's start with our first example. Now the key to being successful on this test is to make sure you know your first 25 perfect squares. That will really help you simplify when it comes to these radicals. So this first one, the square root of 147, I'm trying to think of a perfect square that is found inside 147. Now, it happens to be 49, so 49 times 3 is 147, so I'm going to rewrite 147 as 49 times 3. Now, our multiplication property of square roots that we learned about in this section says that whenever you have one radical, you can break up the values inside the radical as separate radicals. So for example, we have the square root of 49 times 3. So I can rewrite that as the square root of 49 times the square root of 3. Now the square root of 49 is 7, and then the square root of 3 cannot be simplified anymore. There's no more perfect square inside. So we're just going to rewrite that square root as the square root of 3. So our final answer is 7 times the square root of 3. Okay, let's look at another example. So here we have 5 times the square root of 99. So when I see 99, I automatically think of 11 times 9. So I'm just going to rewrite that 5. So 5 times the square root of 11 times 9. Now for the sake of this video, I'm going to write it out as each of those numbers in their own square root. But if you're able to do it successfully without rewriting them out, then feel free to go ahead and do that. So we have 5 times the square root of 11 times the square root of 9. Well, we know that the square root of 9 is 3. So we'll have 5 times 3 square roots of 11. Therefore, our final answer is 15 square roots of 11. The little mushroom guys are getting in the way. 15 square roots of 11. So those are some examples without variables. Now let's look at what happens when we have variables. And if you guys remember, we do something differently when we have even variables and we have odd variables. So for some reason, the square root sign's not showing up. So I will just, there you go. Okay, so we have the square root of 72x to the 16th. So 16 is an even number. So the way you think of perfect squares with variables, since x to the 16th, you can rewrite that as x to the 8th times x to the 8th. Because of our properties of exponents, when you have the same base, you add the exponents. So when you're thinking of square roots, you're thinking of what number do I multiply by itself to get me what's inside the radical. So in this case, let me just erase this. We'll start from the beginning. So 72 is 36 times 2. 36 being our perfect square. And then x to the 16th, since it's even, we're just going to keep it as x to the 16th. We don't need to rewrite it anyway. So now we have the square root of 36 times the square root of 2 times the square root of x to the 16th. Okay, well we know the square root of 36 is 6. The square root of 2, we can't simplify that anymore. And then x to the 16th would become x to the 8th. And that would be our final answer. You usually put everything outside of the square root in the front. So 6x to the 8th times the square root of 2. So now let's try one when we have an odd exponent. So when we have an odd exponent, we need to break that down so that we have one less than what we started with times the variable itself. So in this case, it'd be x to the 8th times x. Notice how that's still x to the 9th. Applying our exponent rules of 8 plus 1. All right, so hopefully I can fit that all in here. Let me see if I can move this stuff down some. There we go. Okay, so let's look at this. We have negative 3x times the square root. Let's think of what is found inside of 80. Now, the biggest perfect square that's inside is 16. 16 times 5. But let's just say you didn't think of that. You thought of 4 first. So we would have 4 times 20 times x to the 8th times x. Okay, so 3x, the square root of 4 would be 2. So now we have times 2. We'll leave the 20 in there for now until we figure out what to do. Square root of x to the 8th would be x to the 4th. And then x we can't do anything with, so we'll just leave that in the radical. Okay. So 3 times 2 is 6. X times x to the 4th is x to the 5th. Remember adding your exponents. Times the square root of 20x. Now we're not done yet. We still have to do some more work because there is a perfect square inside of 20 still. So let's just take this and we will copy it. And let me add a new sheet. Okay. So let's keep going. So we have 6x to the 5th times the square root of 4 times 5 times x. So the square root of 4 is 2. So we have 6 times 2 times x to the 5th. And then inside we still have a 5 and an x, so 5x. So your final answer then would be 12x to the 5th times the square root of 5x. And that would be your final answer. Now notice how if we would have started off finding the greatest perfect square, we would have 16 times 5 times x to the 8th times x. Then we have 3x. The square root of 16 is 4. Square root of x to the 8th is x to the 4th. So inside we still have 5x. When you multiply everything together, the 3 and the 4 and then the x and the x to the 4th, you get 12 x to the 5th times the square root of 5x. So we got the same answer as we did before. Now I just realized there's a negative here, so make sure you make it a negative answer. So little things like that can cause you to slip up. Notice how I made that mistake too. So we should have a negative answer. Negative 12x to the 5th times the square root of 5x. All right, so let's get moving with these examples. So for this one, I'm going to work through it and again just pause it if you're confused and you need more time. So what I would do first is I'm going to find this perfect square in each of these square roots. So 18x squared is 9 times 2 times x squared. times, we have a 7 outside, 4 times 2 times x. Okay, so the square root of 9 is 3. Square root of 2 I can't simplify anymore. Square root of x squared is just x. Remember that square root of 2 comes from here. Alright, so that's the first part. This part over here, we're going to have 7, and then the square root of 4 is 2. So 7 times 2 is 14 square roots of 2x. Alright, so next what we have to do is multiply 3x times 14 and then multiply the square root of 2 times 2x. So let's do that. So 3x times 14 is 42x times the square root of 2 times 2x. Again, 2 times 2x comes from this 2 and then this 2x. So we have 42x times the square root of 4x. But notice now we have a perfect square. We have 4. So taking the square root of 4, that would be 2. So 42 times 2 would be 84x times the square root of x. And that would be your final answer. That one's a little bit more tricky. There's more steps involved there, but if you can do one of these problems, then you're going to be good. You're going to do well on this section. Alright, let's try the next one. And you can't see it because Mario's in the way. Let me move that. Okay. So for this one, let's see what we want to do. We have negative x squared, so let's start with that. We have negative x times the square root of 32 is 16 times 2 times x to the 4th times 3x. Square roots of 7, we can't simplify that anymore. There's no other perfect squares. Alright, so we got a negative x. When we take the square root of 14, we're going to have it times 4. Square root of 2 is going to stay inside the square root, and then x to the 4th becomes x squared. And then again, we have this section over here that we will just leave for now. Okay, so making this a little bit nicer, we have negative 4 x to the first power times x to the second power gives us x cubed times the square root of 2 times 3x square roots of 7. Alright, so next we would have negative 4x cubed times 3x would give us negative 12x to the 4th. Negative 12 comes from negative 4 times 3. And then x cubed times x to the first power gives us our x to the 4th. Times the square root of 2 times 7, which would be 14. So that would be your final answer. Negative 12x to the 4th times the square root of 14. Okay, moving on. Now let's simplify fractions with radicals. So for this, we learned our division property. First, when we look in here, we want to see if we can simplify anything since it's all under one big square root. Now in this case, we can't. So we would take the square root of each of the numerator and also of the denominator. So the square root of 16 we know is a perfect square. P cubed, we want to break that down to p squared times p since it's odd. Now the denominator will just stay q to the 4th because it's even. So the square root of 16 is 4. P squared, the square root of that is p, and then we're left with the square root of p divided by q to the 4th, the square root of it becomes q squared. and that would be our final answer. So this next one. Again, let's look inside, see if you can simplify anything inside before we break them up into individual radicals. In this case, you can't. So we would have the square root of 32p over the square root of 49. So the square root of 32p can be rewritten as 16 times 2 times p all over the square root of 49. Well, the square root of 16 we know is 4, and 2 and the p we can't simplify anymore, so we leave it as 2p. Square root of 49 we know is 7, so there's our final answer. Now notice how the 4 and the 7 can't reduce, they don't have anything in common. Okay, let's see, simplifying radicals by dividing. So let's look at this one. So whenever I look at this problem, I can do a couple different things. I can leave it all underneath the radical and rewrite it as 25 times 3 times x to the 4th times x. That gives me my numerator. The bottom I can rewrite it as 25 times 4 times x. Now from here I can start simplifying. So 25 divided by 25 is just 1, so that goes away. X divided by x also goes away. So I'm left with, in the top, three x to the 4th divided by 4. Now you need to take the radical of the top and the bottom before you do anything now. So you get the square root of 3x to the 4th divided by the square root of 4. From here we can simplify. On top we'd have x squared times the square root of 3 over the square root of 4 is 2, so all over 2. And that would be your final answer. So again, first, before I took the square root of top and bottom, I decided to simplify, and then I went from there. Okay, the next step. Let's look at this one. So, for this one, I would again do similar to what we did the last one where we simplified. 9 goes into 108 12 times. So you would have 12x to the 7th left. And from here it just becomes one of our examples from the beginning. Break down 12 so that the perfect square is there, which is 4. X to the 7th is odd, so you go 1 less. So 1 less from 7 is 6, times just the variable, so just x. Square root of 4 would be 2. Square root of x to the 6 would be x cubed. And then you're left with 3x inside. That would be your answer. Okay, so we have 2 more examples. I'm trying to keep these short for you guys so that you're not watching long videos. Alright, so for this one it looks like my square root got a little bit messed up again. So this should be, let's see here, 7x squared divided by the square root of x. Let me see if I can take that square root. There we go. Okay, that's a little better. Alright, so when I look at this first, big mistake people make is they try and cross off the 7s. You can't do that though because one is in a square root and the other is not. So instead what we have to do is we have to rationalize the denominator. That means we don't want to have any radicals in the denominator. So the way to get rid of it is to multiply the 7 by itself times the square root of 7, and you'll see why. So on top we'll have 7x squared times the square root of 7. Remember, because we have to multiply top and bottom by the same thing. And then the square root of 7 times the square root of 7 is just the square root of 49. And I do notice that yes, we do have a radical on the bottom, but it's a perfect square. So it's going to simplify for us. So on top we'll have 7x squared times the square root of 7 divided by the square root of 49 is 7. Now notice how we can simplify and get rid of the 7's. So we're just left with x squared times the square root of 7. And that's your answer. So the main part here is this right here. You have to make sure you multiply top and bottom because we're not trying to change the problem, we're just trying to change the way it looks. So we don't have those radicals in the bottom. Alright, last problem. So for this one, what I would do is I would simplify underneath the radical first. So 12 can be rewritten as 4 times 3. X cubed can be rewritten as x squared times x. And then our denominator would be 11 times x. So here, what really helps us is just these x's go away. Nothing else really goes away. So before you start moving things outside the radical, you have to take the radical of the top first and the bottom. So now you can take the square root of 4, which is 2. Square root of x squared is x. So you're left with the square root of 3 up top. And then you have the square root of 11. Now before you stop and say that's your answer, I'm going to paste this on another page. You have a radical in the bottom, and we don't want that. So we have to do one more step. So I tried to make these examples a little bit harder, that way you'd be prepared and you would feel confident going into the test. So for this, to get rid of this square root of 11, we're going to multiply by the square root of 11. So on top we have 2x times the square root of 3 times 11, which is 33, divided by the square root of 11 times the square root of 11 is 121. But instead of going through that step, you can just write 11 if you want. 11. Now, believe it or not, 33 does not have a perfect square in there. If you think about it, 4 does not go in there, 9 does not go in there, 16 can't go in there, 25 can't go in there, and then 36 is too high to begin with, so that would be our final answer. So that's the end. Now you have 12 examples to help you study for the test. Again, if I went too fast, you can go ahead and just pause it, do your own work, and then check my answers. You can see that these were a little bit harder. They took more steps. I might have shown a couple different ways, but whichever way you solve it, if you get the same answer in the end, then you did it all right. You know, it's hard to make a mistake on these and still get the right answer, so if you would do something differently than how I would do it, that's fine. Like I said, just see if your answer matches mine. And if you have any questions in class before the test, please come and see me or Mr. Catone. Alright guys, thanks!